Welcome. This is Mr. TG. This is lesson 8.5 from Algebra 2B. Today's lesson will involve adding and subtracting rational expressions. One of the skills in order to be able to add and subtract rational expressions is to find the least common denominator, or we're going to refer to that both least common multiple. It's one and the same. Now, I'll first show you what it is with real numbers, and then we'll branch out into polynomials, and then we'll have you try one. First, number one, we have two numbers, 12 and 18. A lot of you will be able to find the LCM, is the abbreviation for least common multiple, to be 36. It's simply the number that both 12 and 18 divide into. Some people get caught up on the word least. Remember, it has to be at least as high as the highest number. So don't think that it's lower. So the least common multiple is 36. Now, mathematically, here's how we would have to do this. And you may ask, well, why do I have to do it a different way? Well, this is the technique that we have to use with polynomials, so pay close attention. First step with this is to factor the 12 into prime numbers. If I factor it, it's 2 times 2 times 3. That, of course, is 12. I started with 4 times 3, and I broke that down as 2 times 2. With 18, we have 9 times 2, and then break down the 9, that's not prime, 3 times 3, and then we have another 2. So looking at our list of prime numbers for each, we are going to simply circle all factors that are in common. The 3 is in common. We have a 2 over here that's in common with just 1, 2 over here. And of course, the remaining values are different. List those common factors just once, 3 and 2. And then what I call the numbers that are not circled are leftovers. You bring those up into your problem. Another 2 and a 3. And if you multiply 3 times 2, you get 6 times 6 is 36. That is the process by which you find the LCM, or least common multiple. Now you go ahead and try number 2, see if you can find the least common multiple using the math technique I just demonstrated. I know you may know and understand that it is going to be 12. I'm giving you the answer, but I want you to use the technique illustrated here to find that. So I'll put it on pause. You take a moment and see if you can come up with it. Okay, welcome back. As you can see, here's how I derive the 12. You prime factorize the 4 is 2 times 2. 6 is 2 times 3. Circle the common factors, which are the 2. I only listed that just once now. The leftovers that I have as factors are 2 and 3. Multiply all those together. You get the lowest number that both 4 and 6 will divide into. Hence, we call that the least common multiple. Now, again, why am I showing you this? Not trying to make this more difficult than it is. We have to be able to do this technique that I just demonstrated with polynomials. In problem 3, for example, I have 2 polynomials, and I cannot find the LCM, or the least common multiple, of both without factoring, as I did up there. So what we're going to do first is factor each expression. In the first one, I'm going to factor out a GCF of 2. That should be fairly common. 2 goes into both 2 and 4, so I factor it out. The second trinomial, I'm going to factor that into 2 binomials. You guys are getting pretty good at this, so this shouldn't be a problem. You know, notice that 2 times negative 3 is negative 6, and they add up to be a negative x, a negative 1, x. Next step is to circle any common factors. And by the way, if there are not any common factors, you just make a list of all the factors present and multiply them together, and that will be your LCM. But in this case, we have an x plus 2 in common. So we list that once. Bring down the 2 and the x minus 3. And that's as simple as it can be. That is your least common multiple. Or we refer to that as the least common denominator when we add and subtract fractions, which Pearson will walk you through. Now, what I want you to do, using this as an example, you try number 4 and see if you can come up with the LCM, the least common multiple. Okay, welcome back. As you can see, I've completed the problem. Hopefully you match. We factored the first one, x squared minus 9 is the difference of perfect squares. If you FOIL these two binomials, you would get x squared minus 9. The O and I would cancel. The next trinomial, you would factor that into two binomials. Notice again, I circled the factors that are in common, listed that once, brought down what I refer to as the leftovers. That becomes our LCM, least common multiple. We can also refer to this as least common denominator when you get into adding and subtracting fractions. The last example I'm showing you here is our monomials, and I just want to demonstrate to you the same process and how to handle this. You got 12, and then I'll show you a shortcut. 12 times x times x times x times y times z. We got 12, and then we got 24. I'm not breaking the numbers down for a reason here. So 24 times x times y times y. All right, what I am doing is expanding all the variables. First thing I'm going to do to find the LCM of these two terms is I look at the coefficients of my terms, 12 and 24. And if you look carefully, the lowest number that they both go into is 24. So here's a situation where the highest number is your LCM. Now, how do you handle the variables? Well, again, we can just circle the x's there in common. There's one x in common. There's one y in common. There's another y in common. Making sure that we just list them once, not twice, since they occur twice here. So those two are going to be listed. And again, the leftovers that are brought down are x, and z. Did I miss any? I think I've got them all. Now, if you put all these together, you will end up with 24, x to the third, y to the second, x to the second, z. I think we have x to the third, excuse me. I'm missing an x here. There's three x's. So we're going to put a 3 here. So 24, and I already got that. So let's erase that. So we don't need that. So we got 24, x to the third, y to the second, z. That, folks, is the long way of finding the LCM, or least common denominator, of two monomial expressions. A shortcut, one that you could use if you first you look at the numbers, the 12 and 24. 24 is your least common multiple. And then I look at the variables, x to the third, x to the first. It's always going to be the one with the highest exponent. So we'll use x to the third, as we did with y squared. Well, they were the same, so that's y squared. And then if it doesn't have anything to match, you just bring that down as part of your LCD or LCM, whichever you refer to. So the LCM or LCD of these two would be 24x to the third, y squared, z. Hopefully you found this video helpful. Let me know if you have any questions. Now, Pearson's video will go into how to add and subtract fractions. And hopefully you remember a couple things about how to do that from a few years ago. Remember, we must have a common denominator. So, for example, if you have 4 over x plus 3, and I add to that 10 over x plus 3, not a problem as long as these denominators are the same. You would just end up with 14 over x plus 3. Pretty simple problem when you add. The same rule applies to subtraction. The denominators must be the same. It's when you don't have those common denominators, that's when you have to do a little bit more work. And like I said, Pearson does a very good job of showing you that process. So stay tuned for 2 more videos from Pearson, and then I'll be back to show you how to handle a complex fraction. Thanks for watching.